Okay. Let's see. Surface. Surface. Loft. That means you draw a shape between two lines. And we're going to pick this line, that line, make surface. Yeah, that's fine. Won't change anything on it. That's the bottom. Now we need a surface, loft. Should be a line there. A line here. And we'll call that all right. And surface, loft. I got this line. Got that line. And let's see what we got here. I'm going to draw a line across that edge, and a line across that edge. Surface, sweep two rails. First curve is a little thing up here, and that's a rail. That's a rail. Yeah, whatever it comes out right is a sample. We'll go up here and we're going to pick some colors. Blue. And up here on the other side it says edit, layers, change object to current layer. We'll make it that one and this one. Actually, we should be able to join that and that into one piece. Yeah. And then we got another color here. Let's make something that color. Edit, layers, object, current layer. Now I might be able to tell what it is. Not too terrible awful. So do I want to chop some of this off in the back? I want to in the worst way. I want to make a piece for an outboard motor in the back. But first, let's if I wanted to make a deck, okay, first we got to join those things together, make one line. And we're going to make a surface from a no. Surface, we're going to extrude the surface. Extrude a curve straight. And I'm looking at the bottom screen down there just to just to make sure I got it long enough. There's no real length it has to be. Transform, move the surface, this thing here. We don't want it to cut a hole in the bottom of the boat. So we're gonna raise up the only part of it's in there. Backed up here again. Transform. Trick here is not to bring those edges down, because then the things don't really intersect. So okay, we want to trim, I would think, or split. We're going to do trim. We're going to select the cutting object, that big thing. Select the object to trim. Boy, I'm hoping the deck is the red one. No, that didn't work. It sort of worked, we just got the wrong piece. Okay, so now we're going to try it the other way. Split. Object to split. Cutting object. Okay. We're just going to erase some stuff here. Don't need that anymore. It can go away too. Otherwise it'll get involved somehow. Okay, transform. We're going to make a mirror image. All that is going to get mirrored. We're just going to pick this line because it was going off the front of the gizmo. We can tie all this stuff together too, so you can't separate it. That was probably a mistake. I can separate it later though, it's not hard. So now we can look down inside the boat. Looks like a dory. Still want to cut that back end off. I'll do it some other time. Oh crap, wait a minute. Let's just go ahead and chop it off. I don't feel right about it the way it is. Start of a line, we're gonna move this line. I want to cut a little bit of the bottom down there and a bunch of the top. So now we're going to trim. That's the cutting object. Things to trim. Well, they're all grouped together. Should cut all of them. Somehow I missed that. And we get rid of this. Just delete those, don't need them anymore. Don't need that anymore, don't need that anymore. Well, It didn't do it because it was saving. Curve, or from objects, duplicate, edge, 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 edge. And we want to join those, so we're going to hit join. And then we'll see if we can make a surface from a planar curve. Surface, sweep 2 rails. First rail. Second rail. The curve. Okay. Transform. Mirror. That thing. I just included a stray line just because I'm too lazy to do anything about it right now. And there's our piece of a boat with a place to put an outboard motor. This is almost as bad as panning the camera, too bad in the video. Things just whizzing by on the screen. How many minutes? Oh, 13. We're still in business here. Okay, suppose make a copy of that piece of stuff. And then we're going to make a line. And just for fun, we're going to make it straight up and down. Could be an angle, didn't make any difference. But we're just going to make a straight line. And I'm going to copy that line from here to, there's a good place, there's a good place, there's another place, and we'll just stick one here. Don't need that anymore, we'll just get rid of that. Okay. Split. Select objects to split. Press enter. Select cutting objects. Cutting objects. Press enter. Okay, now we're going to ungroup all this thing. Because right now it's supposed to be separate pieces. But it may not be. Okay. Now, if we come in here and pick that chunk, we can delete it. Come down here, we'll pick this chunk and delete it. Don't need these lines anymore. Okay, Now we've made something that'll sink. If I wanted to make a bulkhead that this shape, I don't know. I don't think I ever made this into a solid. No, I didn't make it a solid. If I wanted to make a bulkhead, I'd have to go back and, well, let's just do one of them. Curve from objects. We'll use that edge thing that worked a minute ago. Here, here, here. There, there, there. Transform, move. Well, I wasn't watching my call us what it wanted next. And we're going to join those all together. There you go. Now we can move them. Go from here. There. Surface. And a curve. And there's your bulkhead. This piece will exactly fit that piece. Now, if we want to make it smaller by the thickness of, like we drew the outside of this boat, so there's thickness to the plywood and the fiberglass, and suppose we wanted to make it smaller. Well, no, let's make a copy. We'll do a copy of this whole thing. And we're just going to move it someplace. Now, they're as good as any. Okay, the original curve is in there. So if we take this surface off, normally you would be working this stuff in one of the flat views, because you could take that curve and rotate it around, where you could just put a line and say rotate, and it would rotate that, rotate 3D. It would rotate it around where you could work on it flat. But we're going to see if this will actually work at an angle. I've not tried this. Let's see how we're going to offset that curve. Let's see, distance. Let's stick with inches. No, that's not enough, because it won't make sense that we've done something. Curve, offset curve, distance is 2 inches. That's not going to work down there. Yes, it is, because it's a really big boat. Let's erase that. It's hard to see what I did. Let's take a line here. It's set to do Cartesian, up and down, left and right only. Rotate 3D. We want to rotate that thing. That's the axis. And we'll rotate it 90 degrees. Put in 90. There it is. Curve. Offset curve. Same 2 inches. Okay, surface from a planar curve. Okay, now you got the bulkhead again. But we took off a thickness for the boat. So now this bulkhead will define the inside of the boat. And you can, basically as you put it together, you can press this in and you can measure how far back it goes. You can draw a line on it. That's what we do with the aircraft molds, like fuselage molds. We just draw lines measured off of a common datum point down each curve, and then that tells you where you want to shove that to, and that'll reinforce the shape and make you a rope locker. And then you have this area here that you can sit in and throw stuff up under there. I don't know what this is like a dory. And then you can do the same thing, make a bulkhead there. If you were making say you didn't want to do stitch and glue and you were trying to build a boat with frames, like traditional boat building, wooden frames, you could slice this thing every place you want to put a frame, and then offset it by the thickness of the frame wood down here. Like this would, when you slice your model, you get this line. If you wanted to use like a 1x3 oak or 3/4 by 3, you would make it a 3-inch offset, and that would give you a frame, that you could either measure it, you can turn it into actual pieces of wood and measure what the bevels and the angles are. You can lap them over, you just save half the model and throw the other half away, kind of deal, where you made 2 copies and you save this piece on one and you save that piece on the next one, etc. Make a bunch of copies. And you could, or you could print this thing out and put the wood together right on top of it. Just put a slab of wood up there, mark up with a framing square where the lines are, and then mark a line across and take it to the miter saw. But you could make a wooden frame boat the same way. Unfortunately, we're not doing a frame boat. Too hard. Takes too long. It could take 6 months to build this thing. I don't know, where we at? Oh, golly. 1,000. Oh, wait a minute. I can fix that. I can fix that. Transform, move. I'm going to move all that. Move it from here to 0, 0, 0. Now we have to go find it. So go to the extents of the page. And down here in the corners, this axis, it's so big that it's hard to get it to read oh, you can't see it. Right below this is the off the edge of that line is the coordinates. I don't know if I can do that. It shows you the cursor. You can see it down here. That shows you the cursor moving. Another way to use CAD is to input actual numbers. You get a point and you go from this point, and then you put an R before your coordinate. So it says that's relative to that point. You go so many units in X, Y, and Z, and it'll draw a line to that point. It's sort of like polar coordinates. If you're doing 3D, it'd be like polar coordinates. We're not using angles. We're using three dimensions. So that would be Cartesian 3D. Excuse me, I was wrong a second ago. This is all joined together. I don't know if this is going to work. How about first thing we do is sure want to ungroup it. I know it was grouped together. Surface. Unroll developable surfaces. Let's just select all of them, please. Well, it doesn't want to do it. Well, it will if I pick them one at a time. No, it doesn't either. Anyway, you can pick them one at a time if you want. If we've been going at least a bit slow and watching what we're doing, this thing will unroll the whole blasted thing in one time. That is that part rolled out flat, the one we just highlighted here. That is this. If I had a little thinking time, or if I paused this to think, I would figure out how to select these things. We'll try grouping them. Surface. Where was that thing? Roll develop a surface. Nope, he's only going to do one. It's going to pick a common point, and it's going to join all these pieces together, all over the place here. They won't be on top of each other. They will be individual. Like, we can take this one. We can separate it over there, and we can take this one and move it out of the way. Surface. I'm going to know where that is in a second. Let's pick something down here in the bottom. And that's the bottom piece. So you have a left and a right of this, a left and right of that, and a left and right of this. You pretty much have the shape of the transom, or any bulkheads, because they're already drawn. Anyway, that's just one of the things we play with. We figure out how to do a boat. No naval architecture required. I think as the world goes by and the drawing programs pick up speed where anybody can use one. This is Rhino 3D. I do it to loft aircraft parts. I can change airfoil sections from the route where it goes against the plane or sits on top of the plane, and to the strake, which your wing is a rapid advance to narrower, and then a longer panel that goes out to the tip, and then the tip, and then the winglet. I can have 6 or 7 airfoils going down through there in different angles of attack, and the airfoils on the winglets tilted in, they actually make thrust. And this program will make that surface, and you slice and dice up here, and that can give you stations that you can line up according to the space. You would slice it like on 6-inch centers, and then you put them against a piece of plywood or something, vertical, and you'll have a line down or a notch cut in your drawing so that you can line it up with a notch. And you can form little battens of wood around that you can sand with a power sander and make a mold to make fiberglass. So this program is really good for that. It's of the powerful programs, it may be the cheapest one out there. I don't know one that costs less that does all these things. And they have this is an old version. I started with version 1. I think this is version 4. They're probably up on 8. Version 9, something like that. But I know how to use this one, and I'd have to pay for any other than the one I got. Oh, this company sells a commercial license when you buy it. Doesn't cost you a bit more. You can put it on your computer at work, computer at home, one in your garage. You can have 3 copies running on 3 different computers or 5 computers. As long as they're all yours and you can only use one at a time, you can install it as much as you need it. I've got it installed in the U.S. and I've got it installed on this computer in the Philippines. And it checks in with them every day. They know it's me. They know where I am. If you have, there's some other programs. One was designed by Boeing, the aircraft people. And they wrote a new program. So they sold their program to... who was it in France? Who's the people that build planes in France? Airbus? Well, yeah, the Forerunner's Airbus, but there was a name to them, like Aerospatil or some mess like that. Anyway, they bought the program, and they renamed it CATIA, C-A-T-I-A, and started charging $20,000 for it, and broke it into sections where you had to buy all the stuff that did anything extra. Then you have an annual license you have to pay for it. And then some people in the U.S. bought rights to use it, and they renamed it SolidWorks. And you can still buy it as SolidWorks today. And the SolidWorks is light years ahead of CATIA. It works exactly the same, but it will design things, other things. You can design absolutely anything with it. But all the stuff that you need to make it really powerful, they charge you extra for when you buy it. And then you pay a yearly license to SolidWorks to use the program. End of the year, they shut it down. You don't have a program anymore. You're paying $10,000 or $12,000 for a license, and it only lasts a year. This Rhino was like $780, and I've been using it since 2008. This version here. There's never been a penny of charge. It's well supported on the internet and through the company. McNeil is the people that wrote it, and they have a technical staff. If you really just can't figure it out, then their online forum doesn't help you. You can contact them directly, and they will answer you. Early on, I had a couple problems, but the loft works. You can see we did all these odd-shaped lofts. If I took this piece here and made a copy of that curve, and copy an edge curve, I can divide that into like by 4-inch increments, or I can divide it into so many points along the total length of the curve, if you want to do it that way. And then you offset the line, the thickness you want your holes for your stitching glue, and you have intersections for all those lines down through there. And then you just take a circle, find the center of the circle, and you put it over top of these things, and it gives you something that looks like a circle. Of course, you do that, you want to group all those construction lines you just put on there, so that you can click on any one of them and erase them all and only have the circles left. But this is stitching glue. I think we're going to save that. I don't know why, but we're going to save it. It's 10 minutes of work with it. But what is it? Okay, 32 minutes and 18 seconds. We've designed a boat. We've unrolled developable surfaces that you could print and put together with stitch and glue. We could actually build that boat. We need the transom, but we got the deck, we got a side, and we got a bottom. There's only like 3 major pieces in this thing, plus the transom, which is over here, and it's flat. So you could. Oh no, that's a bulkhead. That's the rope locker bulkhead. Sorry, but in 32 minutes and 50 seconds now, you can design a boat with CAD. That's why there's a dozen models in here of sea kayaks. Some of them wave-piercing bows, low to the water line, sealed with a skirt that goes up around your chest so that when waves break over